Hi, in this video I will talk about compressed gas cylinder safety. Video objectives. In this video you will learn types of compressed gases, types of cylinders, how cylinders are filled, safe use of cylinder related equipment, how to store and handle cylinders, types of compressed gases. Flammables. A gas that will ignite at a low flash point. Examples: propane, acetylene, hydrogen, methane, isobutane. Flammable gas. Precautions. Flammable gases, except for protected fuel gases, shall not be used near ignition sources. Portable fire extinguishers shall be available for fire emergencies. Flames shall not be used for detecting leaks. A compatible leak detection solution shall be used to reveal leaks. Spark-proof tools shall be used when working with or on a flammable, compressed gas cylinder or system. Access doors to areas which use or store flammable gases shall be posted. No open flames. Manifold systems shall be designed and constructed by competent personnel who are thoroughly familiar with the requirements for piping of flammable gases. Consultation with the gas supplier before installing manifolds is highly recommended. Types of compressed gases. Oxidizers. Oxidizing gases are non-flammable gases, but in the presence of an ignition source and fuel, can support and vigorously accelerate combustion. Examples: oxygen, chlorine, fluorine, nitrous oxide. Oxidizing gas. Precautions. Do not use oil in any apparatus where oxygen will be used. Gauges and regulators for oxygen use should be labeled with a warning statement, such as, oxygen, use no oil. Types of compressed gases. Highly toxic. A gas having a health hazard of 3 or 4 as defined by NFPA 704. Refer to material safety data sheet. The toxic action of a substance can have two effects. Acute effects involve short-term high concentrations that can cause irritation, illness, or death. Chronic effects involve continued exposure to a toxic substance over an extended time. Effects can be serious and irreversible. Examples: arsine, phosphate, phosgene, nitric oxide. Highly toxic gas. Precautions. Unless otherwise indicated, all gases must be stored in a continuously mechanically ventilated gas cabinet, fume hood, or other enclosure. Review the material safety data sheet to determine safe use guidelines. Types of compressed gases. Cryogenic. Cryogenic liquids and their boil-off vapors rapidly freeze human tissue and cause embrittlement of many common materials, which may crack or fracture under stress. All cryogenic liquids produce large volumes of gas when they vaporize and may create oxygen-deficient conditions. Examples: liquid oxygen, hydrogen, nitrogen, argon, helium, liquid neon. Cryogenic gas. Precautions. Use appropriate personal protective equipment, including insulated gloves and goggles and a face shield, during transfer of cryogenic liquids. In the event of skin contact with a cryogenic liquid, do not rub skin. Place the affected part in a warm water bath. Use only equipment, valves, and containers designed for the intended product, service pressure, and temperature. Inspect the containers for loss of insulating vacuum. If the outside jacket on a container is cold or has frost spots, some vacuum has been lost. Empty the contents into another cryogenic container and remove the damaged unit from service. Repairs should only be made by the manufacturer or an authorized company. Transfer operations involving open cryogenic containers, such as dowers, must be conducted slowly to minimize boiling and splashing. Excessive ice buildup, especially beneath the vaporizer or tank, could result in the discharge of excessively cold gas or structural damage to the cryogenic container or surroundings. All cryogenic systems, including piping, must be equipped with pressure relief devices to prevent excessive pressure buildup. Hot air, steam, or water should be used to thaw frozen equipment. Do not use water to thaw liquid helium equipment. Types of compressed gases. Inert gases. A non-combustible non-flammable. Displace oxygen in an area. A non-reactive to many materials. Examples: argon, helium, nitrogen, neon. Inert gas. Precautions. Inert gases are asphyxiates and will displace oxygen to produce localized oxygen-deficient atmospheres. Do not use in enclosed spaces without proper respiratory protection. In their liquid state, common inert gases such as nitrogen, argon, helium, and carbon dioxide are also cryogenic, very cold, and can cause serious burns when in contact with the skin. Use appropriate personal protective equipment where required by the material safety datasheet. Inert gases are odorless, colorless, and tasteless, which make them even more dangerous because they cannot be detected by your senses. Types of compressed gases. Corrosives. Corrosive gases react to other materials by eating into or gradually wearing away by a chemical reaction. Can be hazardous to all parts of the body. Eyes and respiratory tract are particularly sensitive. Magnitude of the effect is related to the solubility of the material in the body fluids. Examples: hydrogen chloride, chlorine, fluorine, hydrogen fluoride. Corrosive gas. Precautions. Metals become brittle when used in corrosive gas service. Check the equipment and lines frequently for leaks. A diaphragm gauge should be used with corrosive gases that would destroy a steel or bronze gauge. Check with your supplier. Remove regulators after use and flush with dry air or nitrogen. Wear appropriate personal protective equipment such as safety glasses, goggles, face shields, gloves, etc. Types of cylinders. Non-refillable cylinders. Designed for one-time use only. Refillable cylinders. Steel. Aluminum. The majority of cylinders have an open interior with walls of 1/4 inch steel, a reinforced neck and bottom. Many commonly used gases are highly pressurized between 1500 psig and 2500 psig. For example, oxygen is pressurized at 2200 psig. Cylinders must therefore be maintained in good condition and protected from accidental damage at all times to avoid rupture. The one that got away. Oklahoma State University. 6 220 cubic foot cylinders, part of a fire extinguishing system, had been moved away from their wall supports to allow painters to complete the painting of the area. While moving them back into position, it was noticed that one cylinder was leaking. The painter had the cylinder leaning against his shoulder and was attempting to scoot it across the floor. At this time, the valve separated from the cylinder and was projected backward, hitting the side of a stainless steel cabinet. At this point, the cylinder turned left and took off lengthwise in the room, chasing an electrician in front of it. It crashed into the end wall 40 feet away, breaking 4 concrete blocks. It turned again to the right, scooted through a door opening, still chasing the electrician. He ducked into the next door opening, but the cylinder continued its travel in a straight line for another 60 feet, where it fell into a truck well, striking the truck well door. The balance of the cylinder pressure was released as the cylinder spun harmlessly around in the truck well area. The painter who fell from the scaffold received multiple fractures of his leg. It is surmised that the cylinder valve had obtained previous damage, and it was a matter of chance that it separated from the cylinder at this particular time. Contents under pressure. What happens if an oxygen cylinder, which is stored under high pressure, is knocked over and the valve is damaged? May spin in place. Best option. Leave it alone and back out of the room. May take off like a missile. Worst option. Hope you're not in its path. Types of cylinders. Acetylene cylinders have a porous filler material that helps stabilize the extremely volatile gas. Acetone is used to stabilize the acetylene, but pockets of pure acetylene can develop at the valve stem if the cylinder is not kept in an upright position, or if the cylinder is dented or damaged. Acetylene is pressurized at 250 psig, but free acetylene is highly unstable at 15 psig. Maximum flow rate is 15 psig. Always keep acetylene cylinders in an upright position. If the acetylene cylinder has not been kept upright, let it stand in an upright position for 24 hours before using, or call your supplier for recommendations. Siphon dip tubes. Carbon dioxide is commonly used in both a liquid and gas form from the same cylinder. A siphon, or straw, is used to pull the liquid from the bottom of the cylinder, similar to a glass of water with a straw in it. The valve pulls the gas vapors from the top of the cylinder. Cylinder damage. Effects of heat. Cylinders are designed to expand and contract with pressure changes. Cylinders made of aluminum are affected more than steel cylinders. Arcing damage. from welding operations, dents, from impact or mishandling, corrosion, from moisture, salt, corrosives, etc. Cylinders must be stamped with the following info: cylinder specification, cylinder serial number, registered owner symbol, date of maintenance, neck ring identification, retest markings, cylinder track barcode label, cylinder manufacturer's inspection mark, cylinder tear weight, cylinder labeling, cylinder colors. Do not rely on cylinder color to identify the contents. Color codes can vary from one vendor to another. There are 5 medical grade gases that can be identified by color. All others are not required to be color coded. Where do the gases come from? Air separation plants. Air is cooled until it begins to liquefy and separate into these 3 gases: 78% nitrogen, 21% oxygen, 1% argon. Natural gas mines. Helium, for example, is mined from a total of about 10 mines worldwide. 8 mines between Texas and Kansas, 1 mine in Poland, 1 mine in Algeria. Filling cylinders. Liquids. Cylinder filled by weight. Pressure gauge will not give accurate reading on fill level. Try using a bathroom scale to sit the cylinder on to keep track of how much liquid remains. Cylinder filled with liquid, but used in gas form. Gases. Cylinder filled in cubic feet. Pressure gauge will give fairly accurate fill level. Cylinder filled with liquid or gas and used in gas form. Regulators. Most specialty gases are supplied in cylinders compressed to high pressures. Pressure regulators reduce these high pressures to lower pressures that can be safely used in an operating system. Proper regulator selection is critical for both safety and effectiveness of operating systems. Regulators are designed to control pressure. They do not measure or control flow unless equipped with devices, a flow meter, specifically designed for those purposes. Regulators. Regulator hazards will explode from the front or back. Safest place to be is to the side of the regulator. Keep free of oil, dirt, and grease. Do not use if damaged or defective. Know the history of the regulator, repairs, previous gases used. Opening a regulator. Stand on the valve side of the cylinder as far away as possible, arm length. Do not reach in front of the regulator. Face away from the cylinder when turning the valve. To open, turn the valve counterclockwise. Changing a regulator. Close the valve. Drain the regulator. Back out the adjusting screw. Disconnect the regulator. Do not touch the nut and gland areas. Get another cylinder. Connect the regulator. Closing a regulator. To close, turn valve clockwise. Drain regulator by turning, opening the adjusting screw to release any gas. Reclose the adjusting screw. Regulator tips. Never repair your own regulator. Angle regulators upward if a flow meter is not attached to stay out of the line of fire in case it blows. Wall-mounted regulators with a hose connection to the cylinder may help with access and safety. Valves. If there is a weak point on a compressed gas cylinder, it is the valve stem. If the valve stem should be struck or damaged accidentally, the gases under high pressure will escape at speeds up to 30,000 miles per hour. It's this rapid release that turns the cylinder into an unguided missile. There are 3 types: pressure seal valve, packed valve, diaphragm valve. Valves. Keep valves clean. Do not attempt to open a corroded valve. It may not reseal completely. Remember to remove the plastic caps from the opening before attaching the regulator. Crack the valve slowly by turning the hand wheel slightly to remove dust and debris. Do not crack stainless steel valves. The gases could be hazardous if inhaled. Washers may be required for some gases. Cylinders not having fixed hand wheels shall have keys, handles, or non-adjustable wrenches on valve stems while they are in service. Acetylene valves shall not be opened more than 1/2 turns. Valves shall be closed before moving the cylinder when work is finished. When cylinder is empty. Pressure relief devices. Pressure relief devices are installed on most cylinders to prevent the rupture of a normally pressurized cylinder when it is inadvertently exposed to fire or high temperatures. There are 4 basic types: rupture disc devices, fusible plug devices, combination rupture, disc, fusible, plug devices. Pressure relief valves. Caps. Acetylene caps are larger and will not fit on other gas cylinders. Thread size may vary from supplier to supplier. Never force a cap that doesn't want to screw on easily. Caps must be on during transport to protect the valve stem. Never lift a cylinder by its cap. Torches for welding and cutting. Cutting tip keeps gas mixture and oxygen stream separated. Sized according to the thickness of metal they can cut. Welding nozzle mixes the gas and oxygen in a chamber. Sized for welding various thicknesses of metal. The green hose is connected to the oxygen supply. The red hose is connected to the fuel gas supply. The walls of the hose are constructed of continuous layers of rubber or neoprene material over-abraded in a section. Keep hoses clear of falling metal, slag and sparks, which may burn through the hose and reach the gases. Inspect for damage, cuts, burns, cracks, etc. Test entire hose and connections periodically for leaks. Checking for leaks. Close the torch valve. Open the adjusting screw. Dip hose, section by section, into a bucket of water. Look for bubbles. Close the torch valve. Open the adjusting screw. Apply leak test solution to connection. Do not use petroleum-based products. Always use an approved leak test solution. Look for bubbles. What can happen? A 9-worker crew was modifying a temporary structural steel bridge using an oxyacetylene rig, a portable welder, and a grinder. Apparently, the acetylene hose had developed a leak and ignited during the grinding operation. The torch setup was not equipped with a flashback arrestor, check valve, and the fire traveled through the hose into the compressed cylinder. A nearby worker attempted to extinguish the fire with an extinguisher, but quickly determined it was beyond his capabilities. The area was evacuated, and the fire department arrived to extinguish it. Thankfully, there were no injuries. Cylinder status tag. Upon arrival at the installation or facility, all gas cylinders will be checked for general condition, leaks, and hydrostatic test date. Nitrogen cylinder contents will be with a gas detector to confirm whether the contents are inert or flammable. Cylinders will be marked to indicate they meet the above criteria and the date of which these checks were performed. This sample cylinder status tag provides an excellent method of monitoring the status of a gas cylinder and an inspection checklist to ensure the cylinder is safe to use. Storage requirements. Location of storage area. Away from radiators and sources of heat. Well protected, well ventilated area. Dry area, not on earth, ground. Away from salt, corrosives, chemicals, fumes. Out of exits and egress routes. Protected from physical damage by striking or falling objects. Protected from public tampering. Less than 120°F. Out of direct sunlight. Cylinders must be secured with chain above midpoint, but below shoulder. Cylinders less than 18 inches tall may be secured by approved stands or wall brackets. Cylinders and storage areas must be identified as to contents, oxygen, in, full, and oxygen, out, empty. Cylinders must be stored in an upright position. Separations, clearances, distances. Oxidizers and fuel gases, acetylene, or propane, must be separated by 20 feet. Cylinders, and especially oxygen, must be kept at least 20 feet from highly combustible flammable materials. Oxidizers and flammables must be kept at least 20 feet from sources of ignition. Safe handling. Put caps on cylinders when not in use for extended periods of time. Always keep cylinders secured. Chains should be across the upper half of the cylinder and must be snug. Transportation. In-house. Regulators must be removed. Valves must be closed. Valve caps must be on. Do not drag or roll cylinders horizontally. Secure cylinders in a cylinder cart with chain to move whenever possible. Use platforms or cradles that keep cylinders upright and secured for mechanical lifting. Transportation, vehicles. Transporting cylinders in unsuitable vehicles has led to a considerable number of accidents, many resulting in death. All compressed gases pose additional hazards when transported. For example, flammable gas from a leaking container in the trunk of a car can be ignited by a spark from a brake light, tail light, or turn signal. Another example, an unsecured or improperly secured cylinder could become dislodged during transport, creating a hazard to vehicle occupants. The preferred method of transporting compressed gas cylinders is in the supplier's truck. Alternatively, a suitable vehicle may be used if it has adequate ventilation in the event of a leak and has an adequate method of securing the cylinder during transport. Additional recommended practices: visually inspect the cylinder for dents, gouges, or pits. Ensure that the valve cap is in place and tight. Secure cylinders to prevent movement, preferably in an upright position, especially acetylene. Maintain maximum ventilation by keeping windows and storage compartments securely open. Do not smoke during transport. Take a direct route, avoid route with heavy traffic, and do not make intermediate stops. Be aware that excessive temperatures can increase pressure, resulting in a release of the product. When you reach your destination, immediately remove the cylinder from the vehicle and properly store it. Be aware that some gases are not permitted to be transported in personal vehicles, and that there are maximum quantities of gases that can be transported in certain types of vehicles. Cylinders must meet Department of Transportation labeling, marking, and pleading specifications. Cylinder disposal. If possible, purchase compressed gas only from suppliers who will take back the empty cylinders. Review the Material Safety Data Sheet, MSDS, on the gases being used. Select and maintain all equipment per the manufacturer's recommendations. Store cylinders safely and properly. Handle cylinders in a safe manner. Did you know? Many of us have seen someone inhale helium from a party balloon to talk funny. But did you know that helium can cause you to lose consciousness quickly and without warning? You may literally pass out while still standing. The usual result is an uncontrolled fall that can cause serious injury, even if normal breathing resumes before brain damage occurs due to lack of oxygen. Inhaling helium from commercial balloon filling systems can be deadly, given the flow rate and pressure in these systems. Human lungs can be fatally overpressured in a fraction of a second. Autopsies have shown that the air sacs in the lungs rupture. Death follows immediately, and the victim literally drowns in their own blood. CPR is of no use. Thank you. Feel free to share this video on Facebook, Twitter, Google Groups, and WhatsApp. You can also share it with your professional network on LinkedIn. If you like this video, hit the like icon. To support us, subscribe to the channel and hit the bell icon for updates. Thanks for watching.